Imagine standing at the mouth of a cave where two tunnels vanish into darkness. A marble rolls in, splits like mist, explores both passages at once, and, according to every experiment we've ever run, reemerges as a single solid click in a detector. We can predict the odds of left or right with uncanny accuracy, yet we cannot say, in ordinary language, how the marble chose. That final moment, when shimmering possibility shrinks to a single fact, is called measurement. Quantum theory sketches the journey up to the brink, then closes the curtain. What happens behind that fabric? Does a hidden mechanism spin a cosmic roulette wheel? Do parallel theaters each perform a different ending? Does consciousness shine a spotlight that forces a decision? This remains as our most persistent riddle. The equations are a piano. Interpretations are the songs we play upon it. Copenhagen, Niels Bohr, and Werner Heisenberg imagined the quantum wave as a menu of dishes. While we ponder, all are listed. Ordering observing brings one plate to the table, the rest vanish from the chalkboard. The menu is not the meal. Reality solidifies only when served. Hugh Everett proposed the many worlds interpretation. In this restaurant, the waiter delivers every dish to every version of you. A trillion branching rooms bloom each instant. One where you sip tomato soup, another where you savor miso. No collapse, just an ever-dividing ledger of fates. Christopher Fuchs and colleagues suggested QBism. Here the menu lives inside you. The wave isn't an external catalog, but your personal bet on tomorrow's taste. Observation doesn't sculpt the world. It updates your beliefs after every bite, like a weather app refreshing a forecast after new data. Finally, the objective collapse interpretation by Girardi, Rimini, Weber, and later refined by Roger Penrose. In this kitchen, the overhead light flickers randomly. When it blinks, one potential dish crystallizes, the rest evaporate. Collapse is a real, spontaneous event. Tiny four atoms, but inevitable and roaring for cats. 4 melodies. 1 keyboard. All reproduce interference fringes, qubit logic gates, and laser diagnostics. Yet each paints reality in a different hue. Step into an empty cathedral and clap. Echoes, bounce, overlap, fade. Now, fill the hall with a bustling crowd dialogue. Footsteps, phones. Clap again, and the echo dies instantly, drowned by copies of itself. Decoherence is that drowning, but in silence so small we cannot hear. Every particle whispers its state to air molecules, stray photons, the thermal jiggle of walls. Those whispers multiply 1 trillion times a second, shredding the fragile phase links that let paths interfere. Nothing explodes, nothing collapses. The quantum script is merely overwritten by environmental gossip faster than any cat could twitch a whisker. The result looks classical, pointer straight arrows. Definite locations not because the quantum play ended, but because too many bootleg copies left the theater before the twist could unfold. Wojciech Zurek pushed the metaphor further. He pictured reality as an information savanna, where only the best communicators thrive. A quantum state that broadcasts a clear, redundant story. The atom is here. The table edge is solid, wins countless environmental messengers. Observers sample different shards of that broadcast, and without conferring, all agree. Objectivity is born not from brute collapse, but from redundancy. The same headlines stamped into photons, phonons, dust grains. Competing states that garbled their message, such as delicate superpositions or tangled phase relations, fail to replicate. They go extinct. What remains is the everyday world. The fittest facts, selected by a ceaseless evolutionary contest, waged in the ultraviolet whisper of sunlight and the thermal hiss of air. You might ask, if the math works, why care which story we tell? Well, because stories steer curiosity. Many worlds nudges cosmologists to ponder universes spawning universes, eternal inflation blossoming like foam across unimaginable breadth. Objective collapse inspires engineers to build kilogram-scale interferometers, hoping a tiny random twitch will reveal nature's built-in tripwire. QBism influences AI researcher treating probabilities as personal investments rather than detached frequencies, changes how machines weigh evidence. Interpretation is a budget proposal to the future. It labels some questions fruitful, others idle. The stakes are not only philosophical, they guide which billion-dollar instrument we build next. The next decade may prune the menu. First, macromolecule interference. Physicists in Vienna are preparing to launch organic compounds the mass of a small virus through a 20-meter vacuum tube. Should interference fringes endure, even objective collapse models must retreat to grander scales. Second, optomechanical collapse tests. Suspended mirrors, each the weight of a grain of sand, will be cooled until their center of mass hums in quantum unison. Penrose predicts gravity itself might snap the superposition. A single unexpected jolt would light the path. Finally, macro space mission proposed for the late 2020s. This experiment will cradle a glass bead inside a quiet Lagrange point spacecraft. Free from Earth's rumble, the bead may glide in a Schrödinger-style double path kilometers long. A yes or no pattern could favor one philosophical camp and retire others before the decade closes. Science rarely settles metaphysics in a signature stroke. Yet the boxes we are building now are larger, colder, quieter than Schrödinger dared imagine. They may tip the scales. Yet interpretation alone does not pay the laboratory electric bill. Engineers have already learned to use superposition without untangling its deepest meaning. In Part 4, we'll leave the cat's closed box and tour the bustling factories of quantum. Tech computers that cancel wrong answers, sensors that weigh Earth's heartbeat, and maybe the humble robin that navigates by night on entangled wings.